Well, hello and welcome everyone, and thank you so much for taking some time out of your Tuesday to join us. We're really pleased with the interest that we had in this event tonight, and we're excited to have a number of different groups represented, including Hope alumni, parents of our current students, faculty, staff, students themselves, and community members who are interested in tuning in to learn more together this evening. My name is Beth Studusky, and I'm the Director of Alumni and Family Engagement here at Hope. And I've also been privileged to serve as a COVID student advocate throughout this school year. So I've personally supported over 100 different students in quarantine and isolation so far in the fall and spring semester. And I just have to say that I've been completely impressed with their commitment to doing their part to keeping us healthy and safe on campus. And it's a lot that we're asking of the emerging adults to do as part of their college experience. And I just want all of you to know that you should be extremely proud of the way that they've been handling these challenges. So one of my favorite parts about working in higher education is being surrounded by brilliant faculty who are literally experts in so many varied and fascinating topics. And tonight, we're going to hear from two of those faculty members who probably never predicted that their specific expertise would come in so useful for the Hope community and its ability to be strong during a pandemic. So they are two of the 4 Hope faculty who lead the Wastewater Surveillance and Testing Program. Definitely not a sentence I ever thought I would say as part of an event. And we're lucky to be joined by microbiologist Dr. Aaron Best, the Harrison C. and Mary L. Vischer Professor of Genetics, and also the chair of the biology department, as well as virologist Dr. Benjamin Kopek, an associate professor of biology here at Hope. And they're also joined by Scott Travis, Hope's COVID-19 testing team lead, who provides strategic planning and project management for Hope's entire testing strategy, which you'll be learning more about in just a minute. So I just wanted to run through, you've noticed as you logged in that we're having a cameras off event for you as participants tonight, so you can relax and sit back, not worry about how your hair looks, and learn a lot about wastewater and COVID testing. But we do want to hear your questions. So you'll be able to use the Q&A function. For most of us, that's going to be at the bottom of your screen. And feel free to contribute those all throughout our time together during this event. And I'll be monitoring those questions. And there might be a few that I answer right away in the Q&A function, or I'll share a website or something else that might be a better way to answer the question. But for many of them, I'll be flagging them to be answered live. And that means that we're going to address those questions with the full group at the end of the event. So that's all of the information you need. So it's now your opportunity to sit back and learn about a really exciting and relevant topic from these 3 great speakers.
Thanks, Beth. Thanks for creating the opportunity to do this tonight and for the work that you and the Alumni and Family Engagement team are doing to connect alumni and families and friends of the college in new ways during really challenging times. We're really excited to be here. It's an opportunity for all of you on Zoom. Thank you for joining us. And then also for those of you tuning in on Facebook Live, welcome and thank you for joining us. We hope that each person takes away something tonight in different ways, and we'll get into that a little bit later. I have no idea what I was doing for Mardi Gras last year, but I guarantee it was not providing a webinar talking about how I've worked with a team of people to detect a virus during a pandemic to keep campus safe for on-campus learning. That was something that surprised me. That was not something I saw coming, and it adds new meaning to the idea of other duties as assigned in the job description, as I'm sure many of you joining tonight have had happen in your own lives in so many ways. We've learned a lot in the last year, and we're applying what we're learning from last semester to this semester. And the goal of tonight is to share what we're learning with each of you. You're all coming at this probably from different places. I know from checking the RSVP list that we had a number of different perspectives represented. So you might be a Hope graduate just looking to see what's happening at your alma mater. We hope that tonight informs you. You might be a Hope family member that's really interested in how all this impacts your son or daughter, your student at Hope. And so we hope that you learn about that as well. And then we do have members of the community, other leaders at other organizations signed up that don't have a direct affinity to Hope, but are interested in learning how to mitigate COVID-19 in their own communities. And so one of our goals is to share lessons learned with that community as well. And like I said, we hope everyone leaves with something relevant to our lives in this ongoing pandemic. Our overview for tonight, we've prepared about 40 minutes of content. You can see the topics here. We'll kind of go through these in order with Ben and Aaron and I. And then at the end, we'll have some more of an open panel discussion feel, talking about some lessons learned. And then we'll get to the questions like Beth mentioned as well. So let's get started. We're going to jump in with Virology 101 with Ben Kopec. And early on, he thought he was going to be on sabbatical, I think, even in Europe at a conference with other virologists. And obviously, when the pandemic happened, that wasn't able to take place. And we benefited from that because he spent his sabbatical with us on campus, staying home and helping think this through. It's been a pleasure working with Dr. Ben Kopec, and he's going to share a little bit about virology to get us started, but then overview the framework and our approach at Hope. So Ben?
Thank you. Good evening, everyone. It's a pleasure to be here. My favorite class to teach is virology. So I love talking about this. So when I think, I'm sure most of you know that a virus is a microscopic infectious agent. However, I think of viruses as molecular machines. They're insidious parasites. When a virus infects a living cell, it takes over the normal cellular machinery, turning that cell into a virus production factory. Now, every virus does this differently, but the goal of the virus is to make more virus. Amazingly, the virus is completely able to take over the cell, despite the fact that the cell is much more complex than a virus. Can you go to the next slide, please, Scott? Viruses consist of a protein shell or a coat that encloses its genetic material. Some viruses also have a fatty or lipid envelope that surrounds them as well, which can also have proteins sticking out of them. Now, the size of most viruses is barely larger than the smallest of cellular components, and viruses are hundreds to thousands of times smaller than the typical cell they may infect. If you just look at the genes, number of genes, the simplest viruses have just 2 to 3 genes compared to the tens of thousands of genes expressed in an infected cell. Yet, despite this simplicity, they can easily force the cell to do its bidding. In these visualizations of a virus particle shown on this slide, we can see the fatty envelope studied with large proteins. Inside, Scott, can you go back one slide, please? Yeah, inside here, we can see the strings of viral nucleic acid shown here in red, which are coated by another viral protein. Now, all other organisms, you, me, your dog, the fruit flies flying around your banana, and the bananas themselves have a nucleic acid genome that's composed of a double-stranded DNA molecule. That beautiful double helix structure made famous by Watson and Crick. You'll see it in crime shows, science fiction films, art. In human cells, you contain a DNA genome with all the instructions or the blueprint for how to make you. A unique aspect of viruses is that their nucleic acid genome, or the blueprint instructions for how to make a virus, they can be DNA, like that found in your cells, but they can also be composed of RNA. And RNA is similar to DNA in that it can encode information in a letter code, but it has other physical properties that are quite different. Now the coronaviruses, next slide, please, which are the current subject of the current pandemic, are a family of viruses that contain RNA genomes. And they got their name when they're first seen under an electron microscope, like the black and white image shown on the left. Apparently, the first scientists who saw these viruses thought they looked like they were wearing a crown due to those spike proteins sticking out of them. And this electron micrographs, we can see the RNA genetic blueprints, which have been colored here in yellow inside of the viral particle. That gray colored material is the fatty envelope, which, by the way, is nothing that the virus produces, but it's just stolen from the cell itself. And of course, the protein spikes shown here in red sticking out to make that beautiful crown. Now, despite being the kings and queens of the virus world, coronaviruses were largely ignored by the public and even most virologists. The first human coronaviruses were identified in the 1960s, and 4 different human coronaviruses are commonly circulating in the population. However, the coronaviruses were ignored because they didn't really cause severe disease. You'd probably hardly notice the mild cold-like symptoms of a typical coronavirus infection. However, this all changed in 2004 when a virus emerged that caused severe acute respiratory syndrome, also known as SARS. The causative agent of SARS was quickly identified to be a coronavirus. And I distinctly remember being in class in graduate school, my professor remarking that he didn't believe SARS could be caused by coronavirus because coronaviruses were, quote, too wimpy. Now, boy, was he wrong. And I know students really love it when the professors are wrong. Still, what became known as the SARS coronavirus spread quickly, but also died out pretty rapidly. The good thing is that the scientific community really stood up and took notice and began studying coronaviruses and looking for them in nature. Next slide, please. Now, for most people, this coronavirus pandemic seemed to come out of nowhere, and others say we could never have predicted it. The truth is, scientists have been predicting such a coronavirus-driven pandemic since just after the first SARS-CoV outbreak. I found this scientific paper from early 2019 entitled appropriately, Bat Coronaviruses in China. Now, this paper is just a review of decades worth of research in this area. In the abstract, I highlighted text that says, thus, it is highly likely that future SARS or MERS, which is Middle East Respiratory Syndrome, like coronavirus outbreaks will originate from bats, and there is an increased probability this will occur in China. Now, this work was published a year before SARS-CoV-2 even emerged. So although we appear to be taken by surprise, scientists have been intensely studying coronaviruses now for decades. Next slide, please. Now, if we look at what we learned, and we look at the anatomy of the SARS-CoV-2 virus, shown here in this colored circle surrounding the virus particle, those are the viral RNA blueprints. There are 30,000 letters in this blueprint compared to the 6.4 billion letters that make up your genome. Most of those letters, shown here in this yellow-orange color, encode genes that are involved in the replication of the virus. The red part of the genome encodes this red spike protein, which gives the virus its crown. And if you're fortunate enough to have received your vaccine, that shot would have contained this short red snippet of RNA, which would cause your cells to produce this red spike protein. Your body would then recognize that and as foreign and thus be primed should you encounter the real thing. Now, there are a few other features of importance here related to the wastewater discussion in a moment. When we are detecting virus in the wastewater, we're not detecting that whole virus particle. We're just looking for snippets of that viral genetic material. In our cases, we're just looking for the snippets of RNA in this region in the bottom right of that circle there, bottom right of the screen, in that purple labeled N or E. So we're just looking for those snippets, small parts of the virus, not the entire infectious virus particle itself. Next slide, please. But why are we looking in sewage when SARS coronavirus is a respiratory virus? It's certainly true that SARS-CoV-2 spreads through respiratory droplets and mostly causes respiratory symptoms, but it certainly leads to other symptoms as well. And the receptor for SARS-CoV-2 is present in many cell types. There's not quite solid evidence yet that SARS-CoV-2 replicates in the gastrointestinal tract, though it can produce diarrhea as a symptom. Regardless, these salivary and respiratory secretions that are in your upper respiratory tract get swallowed and then travel through your digestive system, where that viral material can then exit into the sewage. Next slide. Of course, there are many viruses found in the wastewater, if you look. This graph shows several different viruses that are commonly found in wastewater at higher concentrations. In the bottom, you see it says virus concentrations. And then on the left of that graph are several different viruses. Now, of course, you'll find the common enteric viruses like the rotaviruses and the noroviruses, which are notorious for their the diarrhea they cause and the intestinal symptoms. And you can see here that some of those are present at levels of billions of copies per liter of sewage. And of course, humans eat lots of different things like plants. So we often see high levels of plants in wastewater as well. And there are actually businesses where you can send away some of your fecal samples and they'll tell you what viruses are in your intestines. Invariably, people become very upset when they see all these plant viruses in their fecal matter. But of course, you are what you eat. And if you have high levels of plant viruses in your stool, you probably just had a really healthy luncheon. But the plant virus shown here, this pepper virus, which is pepper mild model virus, it is an important control for us in wastewater testing. And one we use as a control is because it's present at such high levels. And of course, and unfortunately, recently, we've been able to detect SARS-CoV-2 also in the wastewater. So that is my short overview of Virology 101 and Coronavirus Virology 101. In a moment, I'm going to hand it over to Aaron Best to discuss our wastewater testing program in a bit more detail. But first, I want to provide just a brief overview of our overall COVID-19 mitigation strategy here at Hope College. Now you see this Swiss cheese model, and I've seen this in other popular news sites as well. But when we look at this, there's no one thing, there's no one single strategy that's going to completely mitigate the spread of virus. What it really takes is a multifaceted strategy, and each one of these has a small and then hopefully cumulative effect to drive down the spread of virus. Of course, face coverings and physical distancing, social distancing are major components of that strategy, as well as frequent hand washing and disinfecting surfaces. At the end of every class, as students are washing down those surfaces. We did start this fall semester 2 weeks earlier. I wasn't sure how that would work, but it worked out brilliantly because we were done right before the governor's orders went into effect in November. And so we're actually able to wrap up the semester before things began to shut down. And of course, we have a great team that put together some safety plans. But the focus of the rest of the talk today is really going to be on wastewater testing and our on-site rapid testing that Aaron will discuss. And if we looked at our wastewater testing strategy, and this was something that Dr. Best and Dr. Mike Picard and Dr. Brent Krieger, who were all instrumental and had an ongoing wastewater and water quality research group on campus. And as Scott said, I was supposed to be at the Pasteur Institute, which is every virologist's dream to work at as part of my sabbatical. But things, of course, I could not get over to Paris, France this year, but I was luckily able to get in and work with this great group of faculty to ramp up and begin this wastewater testing. It was just amazing how quickly things ramped up and we were able to get this going. But the strategy, again, Dr. Best will talk about this in more detail. There's a team that actually collects the samples. We work pretty closely with the Holland BPW to identify sites and sewer lines, as well as the physical plant on campus. And so with that wastewater testing, there's individual testing. Wastewater testing is really more of a pooled testing, but then to identify specific individuals who may be infected in those zones. And then those who are positive, there's another team that follows up with contact tracing and can then lead to quarantine and isolation of infected students in close contacts. All right, so now I will hand it over to Dr. Aaron Best to discuss in more detail the wastewater testing strategy and some of our successes there.
Thanks, Ben. Thanks for that introduction. Super interesting, and I learn every time I hear you talk. So that's great. Also, I've noticed that we've got some good questions coming into the chat. So keep those up, and we'll make sure to get to those at the end. So I'm going to talk a little bit about the wastewater testing strategy that we've employed, and we're going to show you a little video here that gives you some idea of the kind of work that's happening sort of on a daily basis around campus. So we have a team that goes out to different sites around campus. We pop manholes in the streets, grab samples out of those, and then take those back to the lab and do work to isolate nucleic acid or the RNA of SARS-CoV-2 out of these samples. We do that in sort of these biosafety hoods here that protect both the user and the sample, so that we can do this in a safe manner. One of the things that we wanted to do here was to employ an approach to use wastewater to help us understand the potential burden of SARS-CoV-2 on campus. And the approach is not a new one. It's called wastewater-based epidemiology. And that approach has been used for years. It can be used to monitor for drugs that might be in the sewage system, various other chemicals that might be produced via manufacturing. And it can also be used to detect microorganisms, including viruses like Dr. Kopik was describing a bit earlier. And one example of this is for use in detecting polio. So polio is nearly eradicated from the planet in terms of being a causative agent of disease. And wastewater-based epidemiology has been used routinely in that context to guide vaccination campaigns around the world. So even if you're not aware that there might be polio cases in a particular area, you can test the sewage for it. And if you see positive identification of the virus there, that can help you to direct your vaccination campaigns, your communication campaigns, and those kinds of things into those areas. So the use of wastewater epidemiology is really being applied to SARS-CoV-2 in order to help us get a handle on the pandemic in various situations. Next slide, please. So some of the advantages of this are these. For SARS-CoV-2, it's very possible that detection of SARS-CoV-2 RNA in the wastewater can give you an early warning for when people are actually infected with the disease. And beyond that, it can actually tell you, so it can do that before people get symptoms, right? So before you would know if you have an actual clinical case of SARS-CoV-2. But beyond that, it can actually give you information about people that have the disease, but don't even know that they have it, right? So they never become symptomatic. In those cases, those people are infectious. So if they're walking around and not following distancing guidelines or masking guidelines, then they can easily pass that to other people. So this allows us to detect that kind of situation. That's actually super important on a college campus as well. So it turns out that many of the infections in student age populations are mild infections. So people think they just have a cold or they're completely asymptomatic. So this gives us a handle on that kind of disease. It's also a population-wide approach. So as Dr. Kopik mentioned, it's essentially a pooled sampling. So we take the sewage that's exiting buildings or running under the streets, and so it represents everybody that is present in that zone or in that area that's contributing to the sewage. So it allows us to test a lot of people with a single test instead of having to test people individually. That leads to a lower cost, so it allows us to screen the campus essentially for many fewer resources than if we were to, say, test everybody on campus twice a week, which is an approach that many places are taking. It also allows you to understand what the trends are and the potential burden for the disease in an area. So in our case on campus, so you can see signal present or not present. You can see the signal increase and decrease. And so you can, from that information, you can gain sort of an understanding of the overall burden that is occurring in the area, and understand if you've got an increasing problem or if you're sort of through a peak or through a problem, and that you can expect fewer cases in the future. Next slide. So I'd like to describe a little bit about our approach here on campus, and Hope College is a fairly small campus. We have 3,300 students, but we're able to use this approach to monitor about half of those students that are living on campus in any of our dorms or apartments or cottages. We've taken an approach where we've broken down our campus residential zones into 9 different areas. We cleverly named them 1 through 9. And each of these areas is monitored on a daily basis. Each zone contains about 100 to 250 students that are living there. Some of the zones are restricted to a single building. Other zones are representative of multiple buildings, multiple residential halls, and in some cases academic buildings as well. We've done our best working with Holland BPW to sort of figure out what the sewer system underneath Hope College looks like. I will also make the statement, I never thought I would care about what the sewage system under Hope College was, but I do now, and I'm pretty familiar with it at this point. And so we access those different points, and we chose the different points to sort of optimize our ability to screen. And it's a balance between being able to process samples quickly, the number of samples that you want to do daily, and then being able to get information as fast as you can. We also decided to monitor our isolation and quarantine primary facility, which is the Hayworth Conference Inn. And that actually turned out to be isolated. So we got lucky in many cases that the sewage system under Hope College was actually accessible in ways that were highly useful. So we used that isolation quarantine zone almost as a positive control. So we know when students are isolated there, they are infected, they should be shedding virus. We can detect that and ensure that the entire system is working. We're collecting samples on a daily basis from Monday through Friday. So we set samplers in the morning on the previous morning. So we would set a sampler on a Sunday morning. We would collect samples over a 24-hour period and get what's called a 24-hour composite sample. That is collected the next morning on the Monday, say, and then that's brought back to the lab and we process that. We've chosen a method that allows us to do that quickly and inexpensively, and so we get same-day results. So we have results for the SARS-CoV-2 signal that evening. Those results are then communicated directly to the decision-making team that's involved with overall testing strategy and approach to working with students who may have SARS-CoV-2. And so we do that on a daily basis. The wastewater testing is integrated into that overall strategy. We'll talk a little bit more about that, but we had pre-arrival testing, we have symptomatic testing. So if a student is feeling any symptoms, they can come get a test at the clinic. We also have a random surveillance component. So for those students that are not in a residential zone that's covered by wastewater monitoring, we're doing a random sampling of those students daily. For those that are in a wastewater zone, we don't test those students on a random basis. We only test those students when there's an indication from the wastewater itself that there's SARS-CoV-2 present. Next slide. So the basic approach that we're taking here, just a little bit so you know kind of what's going on. We are collecting those samples. So you see a picture of an open manhole there. The sampler in this case is broken apart. And so they're collecting sample out of this at that point. What happens is you take the liquid, the sewage that's in the carboy there, and you mix it with some salt and you mix it with some ethanol. And what that does is that stabilizes things when viral particles are broken apart. So when the viral particles are broken apart, they will sort of spit out the nucleic acid that's on the inside, the RNA genome, and that gets stabilized by this condition so we can transport back to the lab. Once we do get it back into the lab, we do a filtration on that to get rid of sort of large particles. All of the nucleic acids come through that filter. They don't get captured by the filter, and they come into a liquid phase at the bottom of that. We then take that and then process that through a capture mechanism that allows us to capture the RNA from all of the liquid that's there, and then we wash that off. So we wash things that are, the contaminants that we don't want. At the right time, then we can then take the captured RNA and bump that off of that column and into a tube, and that's sort of a purified set of nucleic acids that we can then analyze downstream. The method that we're using to analyze that downstream is called RT-qPCR, or reverse transcriptase quantitative PCR. And this allows us to take RNA, turn it into DNA, and then detect those two genes that Dr. Kopek was talking about. So for the SARS-CoV-2, we're looking for small parts of the gene N1, and we're looking for the N1 marker inside that gene. And then the other gene we're looking at is called E. We are also looking for the pepper mild model virus. That was the plant virus. So if you're eating peppers and things like that, you are excreting that into the system. I realize that nobody really wants to think about what's happening in the sewage system. So usually you just send stuff down the drain or flush it, and you don't ever have to think about it again. And that's certainly how I used to think about things too. And that's sort of ideal, right? But there are lots of ways to detect things in sewage and understand what's going on in the system. So we're exploiting that. So the pepper mild model virus allows us to control for the potential differences that might occur for fecal content in a sewage sample. So sewage is not just what's going down the toilet. Sewage is also water coming from cooking, or water coming from taking showers, and other types of things. It could be storm water that's coming into the system, depending upon how your local system is set up. So we have to understand a little bit about what the variation is in the fecal content that's there, because our expectation is that the SARS-CoV-2 is traveling with the fecal content. It's not traveling with all of the other stuff that's coming through. Next slide. All right, so we were able to do this, to take this approach by building a team, basically. So this kind of all came out, I'll say this. So, back in March of 2020, I think we were heading into the shutdown, I'm not sure, but I think I was doom scrolling on Twitter and kind of working through, my Twitter feed is mostly science people. And I ran across a tweet from Dr. Aaron Bivens at Notre Dame. And it was something like, hey, let's think about using wastewater for SARS-CoV-2 detection or something like that. I don't remember exactly what it was, but I thought, you know what? That seems like a pretty good idea. And I kind of work on water stuff, not really wastewater, but we'll see what happens. And so we got to talking a little bit on Twitter, but then that sort of blossomed into this international Slack channel, actually, that allows people to talk about wastewater testing. And that kind of put an idea in my head to think about, well, how can we do this on campus, right? How can we set this up? And then at a TGIF type gathering for the biology department during March, because we were all isolated from each other. I think I brought this up, and Dr. Greg Murray, who's an ecologist in our department, said something along the lines, well, why don't you just test every building for this stuff? Because I was kind of struggling with how exactly to do it. And I thought, that's a great idea, so let's do that. So that kind of evolved into, well, let's make this happen. And so in July, we made a proposal to the administration that we could, in fact, do this on campus. And then that turned into a decision to go ahead. And so between July 15 and August 17, when students came back on campus, we ramped up from 0 to a fully operational system. We did that through collaboration. So the faculty members that are listed there, but we also had some existing personnel in place that were able to pivot over to this kind of activity. So we created a wastewater project management position, and that's Adam Slater, a wastewater field supervisor, so that we could get all the field logistics figured out, and that's Randall Wade. And then also a logistics person, Sarah Brokus, and those three are in my lab and have been for several years, and we're able to take their skills and shift over. We then created new positions, wastewater lab technicians, who go out into the field every day and collect samples, but then also process samples in the lab and do the detection on the various instruments that we have. These are Skylar Brunink, Amy Olgers, Kyle Ross, and Danny Wade. And you'll notice that they're all graduates from May of 2020. So we were able to take sort of a really poor job market and give them something to do for a while, and it's worked out really, really well. That's the 4 technicians that are pictured there in my lab. Next slide. So I want to give you a brief look at what some of the data from doing this process looks like. We've created a dashboard that allows us to have sort of a live interactive view into the data that we're getting on a daily basis. Up in the upper right, there's a map of the Holland area. The little orange dots are every one of the sampling points that we have on campus, the 10 places that we're monitoring. And then the orange dot that's a little off to the north there is the wastewater treatment plant for Holland. It services both the north side and the south side of Holland. And so we've been sampling there as well. The lower right panel gives you a live look at the number of cases that are occurring in Ottawa County and the number of deaths that have occurred, and you can see that over time. And that's just updated all the time from the public health department. On the left side is the data pane, and this is the pane we use sort of all the time. And what it does is it shows us for any one sampling event whether we see signal for SARS-CoV-2 or not. The blue bars are a detection of the N1 gene marker, and the orange bars are a detection of the E gene. We like to see both being detected. We don't like to see them, but when we do get detection, we want to see both of those detected. It gives you some confidence that what you're seeing is real. They generally track together pretty well in our experience. And you can see that there's variation there. So the y-axis, the vertical axis, is giving you a measure of the concentration, essentially, of the sort of the number of copies of genes that are identified at any one time point. And so you can see that varies, right, from basically no detection to super high levels, and it comes back down, and then it goes back up, and those kinds of things. So those are the kinds of information that we're using on a daily basis to make decisions about whether we should follow up with testing in a particular wastewater zone. Next slide. So what I'd like to do here is kind of take you through a SARS-CoV-2 wastewater event on campus, and kind of walk you through what we're doing daily, and then kind of how we're progressing through something. This is one of the earlier events that occurred in the fall. I'm not giving you dates, but or the zone in which it occurs, but it's one zone. It's about 200 to 250 students in that zone. What you'll notice on the lower part of that is I've labeled things as event days, so 1 through 16. The y-axis is again this measure of the amount of SARS-CoV-2 that's present. So the higher it is, the more SARS-CoV-2 is there. Each of those numbers is under 2 bars. Remember, we're detecting 2 things. So you have a blue bar and an orange bar. That's day 1, and then day 2, day 3, etc. All right, so on the far left of the graph, you'll see a series of days that aren't labeled, and you can't really see bars there, right? So it's not that we're not running tests. We're doing that every day, but we're seeing those as non-detect. So we're not seeing SARS-CoV-2 present in the wastewater from that zone on those days. Along about event day 1, we start to see signal come in, right? So you see 2 bars there, they're reasonably low. We weren't really sure what to do with that, so we decided to wait a little bit and see what the next day looked like. You see that it's increasing on day 2. And so at that point, we began to think about, well, what should we do? And so as a test team, we discussed what the right step was. So basically what we did is we increased our surveillance testing that was already going on in that particular zone. We did that on day 2, I believe. You can hit that, yeah. And so that's what that white arrow means. That means we instigated an event, a follow-up event. You see that the signal is still increasing on day 3. It's kind of coming down a little bit on day 4. Days 5 and 6 of the weekend, right? So we didn't test on that. Keep going. While our surveillance testing that was increased because of this did actually identify a couple of students in that zone that had SARS-CoV-2, and they were removed into isolation quarantine facilities at that point on that Saturday, day 5. On day 6, the testing team got back together on a Sunday evening, I think 6 p.m. on a Zoom call, and we all got together and said, what should we do? And then we decided at that point that we really did need to test the entire zone. So we followed up, so we basically put together the logistics to be able to test all students that were in that zone. Next. As the week progressed on day 7 through 11 there, we could continue to see signal. It's kind of bouncing around a little bit, but it's consistent, right? It's there the entire time. We decided to do the testing event. It took us until Tuesday to be able to do that. And the type of test we had to use at that time was a PCR-based test, and we had to send it out. So we had to ship it out, and then there was a 2 to 3 day turnaround time. So this is not ideal, but we were still able to test everybody. Those results started to come in around day 10, 11, that Thursday, Friday of that week, and we were identifying more students that had SARS-CoV-2. I will note that all of the students at this point were asymptomatic, so none of them had any idea that they were infected, and nobody else did either. So we were able to identify them that way. Along about day 12 and 13, that's the weekend again, so we're not sampling, but day 14, we started up sampling again, and you see that the signal has gone away, right? So you've identified the students in the zone that have COVID-19, you've removed them into their isolation facility, and they're no longer contributing to the wastewater, thus the signal goes away. You might be asking yourself, what is happening on day 16? Well, we asked that same question, and then when we started to think about it a little bit, we realized that the first students that were identified as part of this were exiting their isolation period. So it's a 10-day isolation period. So along about the 16th, that 16th day, they came back in, they started to contribute to the wastewater signal again, and voila, we see the signal come back. And it doesn't mean that they're infectious. So after 10 days, you're not infectious anymore. Okay, those are the guidelines. But it is understood that people will still shed virus in their stool for multiple weeks up to months after they have had COVID-19. And so we can see that as a pattern. So I use that as an example. This is one event. Next slide. We're using this, and we're confident that we can see patterns that allow us to make decisions and make decisions real time. We used this approach last semester. We did 29 follow-up events where the wastewater would have instigated testing of individuals in a particular zone. We found 41 positive cases, all asymptomatic. That represented those percentages of the cases on campus. Remember, we have all this other sampling going on. And then the spring semester so far, we've identified 7 positive asymptomatic cases, in the last three-ish weeks, essentially, of monitoring. Next slide. So we were doing this, and as part of for hope, essentially, and also interacting with the community, monitoring Holland's wastewater treatment plant. But in September, October timeframe, Michigan decided to put together a statewide monitoring pilot program to see if they could ramp up capabilities for labs to use this across the state. So this was a program through Eagle, former MDEQ. And so that pilot project is still running. It actually ends today, I think, or yesterday, the 15th. And it was a network of 17 different public health departments and then associated laboratories to monitor SARS-CoV-2 across the state. It provided an extensive amount of funding, so about $500,000 to Hope College to ramp up testing and to do the kinds of testing that we're already doing, but to sort of expand that. As well as another $200,000 to $300,000 worth of equipment that we've pulled in the last 3 months. And this is an example of one of the pieces of equipment. It's a digital PCR instrument. It's more sensitive, and it allows you to do some different kinds of detection that the qPCR doesn't allow us to do. So we've been able to be part of that project. I think there's opportunity for that to continue on. If any of you know any legislators in the state, please contact them and say it's worth doing. I think the state is still deciding what to do, but there's potential for funding through the HHS, the Health and Human Services Department in Michigan, over the next, maybe for the next 2 years, to be able to do this kind of monitoring. Because of that, we were able to monitor Allegan. We worked with Allegan County as well as Ottawa County public health departments, communicating to them sort of weekly information on what the SARS-CoV-2 in the community was doing. So we monitored at 3 different wastewater treatment plants: Holland wastewater treatment plant, Zeeland's wastewater treatment plant, and then Allegan as well. So what I'd like to do is show you just one example of what the Holland wastewater treatment plant signal looked like through the fall. So next slide. And I want to use this to show you really one thing. So this is a graph where the dates are along the bottom. Looks like that's from June. Is that an 8? Yeah. So August through December, essentially. when we started our monitoring program. The red line is this same value that you saw in the blue and the orange bars, just graphed a different way. And it's not on campus, it's at the wastewater treatment plant. So it's a combined signal from both the north and south side. The blue line is the number of cases that are being reported in the county on that same day. Okay, so what we're doing here is we're comparing what the clinical presentation of SARS-CoV-2 COVID-19 is in the community, in the surrounding area, and then what the wastewater signal is doing at the same time. So you'll note that this blue line comes up here. That's actually right at the beginning of September. Remember, this is actually countywide data. That bump right there is not Hope College. It is not Holland. It is not Zeeland. It is Allendale, as GVSU starts to come back. And so you might remember that there were news reports and they had to shut down for a couple of weeks or shelter in place for a couple of weeks because of those spikes. So you see some movement like that. We saw no signal in the wastewater, or very low signal in the wastewater during that period in September. But what you'll notice is along mid-October, you start to see that signal come up, and it comes up dramatically. And you start to see the case counts rise too, but the case counts didn't actually peak until a few weeks, a week to a week and a half later. And so what I think this means is that the SARS-CoV-2 signal that we're seeing at the community level is actually preceding the signal that you would see from clinical presentation of the virus, so probably by about a week. You'll note that we had this sharp drop off right at the beginning of November. The state didn't shut down, remember, until 2 or 3 weeks into November, right? So the signal from the wastewater could have told the state in some cases that they were doing this across the state, potentially to make decisions earlier than they did. You'll notice here that the signal doesn't go all the way back to where it was. It hits a new baseline, is what I would call it. So there's just a generally higher level of SARS-CoV-2 in that system. And then we see that kind of continuing. So I think that's what I have with respect to the wastewater. So I will give it back to Scott.
Thanks, Aaron. So we talked about how we detect SARS-CoV-2 in the wastewater. The question is then what? What do we do after that? And we do have to do individual testing. So as both Ben and Aaron said, wastewater is a type of pooled testing, and that's told us maybe within 100 to 200 student area, we know that the virus is there. And so that's where individual testing comes in. It's important to note as we start to talk about individual testing that it's just one component of the overall mitigation strategies. And it's all of them together, that kind of Swiss cheese analogy that Ben had, that really make the difference. So just because a community is doing testing doesn't mean you should back off on those other things. They all kind of work together. But testing is an important part. Since the pandemic started, we have conducted 17,500 individual tests. Really starting in July and August up till today. And what we recognized early on was that we could have supply chain issues and or lab delays. And so we very intentionally started to procure testing supply from different providers. So we have now used 6 different types of individual tests. Some are antigen based and get us quicker results. Some are PCR based and need to be sent to a lab. And we use those kind of strategically in different components. And it's also a great place to stop and mention Cindy Sabo, our director of the Hope College Health Center, and her team of RNs. And there might not be any other group than nurses that are ready for this pandemic to be over. So for all of you tuning in, I have a homework assignment. Text a healthcare professional tonight and say thank you. And it's a chance for me to thank Cindy and her team. The types of individual testing that we're doing include baseline testing. So at the beginning of each semester, we've gone through this twice now. That includes pre-arrival testing with kits that we get to students at home. They take it on a supervised Zoom call with a third party and then send those into a lab. We then get the results back a day or anywhere from 1 to 3 days later, depending on shipping and lab times. And then that clears them for campus, or they delay arrival. For those that doesn't work, or they arrive early or for a different reason, we have provided on-arrival testing. And then if they test positive before moving in, instead of going to move in, we isolate right on campus. So baseline is this combination of pre-arrival and on-arrival. And in the fall, that led to 38 delays in arrival or isolating on campus. And then this spring, as the prevalence in just the larger community was still high over the November, December time as we got out into January, we did have 64 that delayed arrival or isolated on arrival, which allowed us to start the semester with that clean baseline. That was important because that allows us to then shift over to surveillance testing. And that is the combination, that's what Aaron shared with wastewater. We're doing follow-up testing in zones, like Aaron mentioned, and then we're also doing a random sample every day from those that don't live inside that wastewater umbrella. So that's our surveillance testing. We have a test center set up on campus that the students are all too familiar with now. And as Beth mentioned at the very beginning, we continue to be very happy to see how students have responded and the resilience that they show and their cooperation in all of this. And so if you see a HOPE student, thank them for their participation in all this. We also do subset testing. That's basically residential life, athletics, different testing protocols, either because of MIAA or NCAA competition. And so we have some different things going with those groups. And then importantly, we're asking students to monitor symptoms, and then they can make an appointment with the health center and complete a symptomatic test. And about half of our positive cases among the student body are from symptomatic testing, and then the other come out of that surveillance and subset testing. If you're interested in learning more or following along throughout the semester, you can check out hope.edu/coronavirus. It takes you to this page. That COVID-19 testing data link will bring up our dashboard. We have a public dashboard. It's updated every Monday morning. And so it tells you the number of active cases. This is from this Monday morning, our positive rate, the number of tests, much of the information that we're sharing with you here tonight. I'm going to do a quick overview. This is kind of what Aaron did with walking you through an event. I'm going to walk you through the semester. And so this is the fall semester. You can see the blue bars there are the number of tests conducted. And then the orange line is our 7-day average positive test rate. And you can see the arrival test spike, a lot of volume of testing on pre-arrival. The positive rate goes up, and then we have it drop down as we start classes. You can see us switch to our first couple weeks of surveillance test. At this time, we were just doing a 1% sample overall. We didn't do the wastewater follow-up yet. And then in September, you can see the spike kind of in the middle there. That's actually an event like the one Aaron outlined. Our wastewater sample where we get the results, we then do the follow-up testing individually. And at about that time, we also had our first batch of antigen-based rapid response tests that we could administer ourselves. And so that also added and changed the dynamic of how much we're able to respond when we saw the increased signal in the wastewater. And then October, we actually hit our 7-day positive rate. Our low was on October 12th of just 2.2% was our positive rate. But at that time, we saw the community data that Aaron showed you, and then we also started to see cases go up in the community, and we were a little sheltered from that. We could kind of see it growing around us and got ready for that. And sure enough, by mid-October, and you can see as we get into November, our positive rate went up. The high point was 7.7% positive rate. That was still below, quite far below county, state, and national at the time. And that's where we had more cases detected. We increased our testing, as you can see, during that time as well, pretty much to as much as we could do. And then we started to see, we kept the level of testing high. We did start to see the positive rate go down. That's when we approached departure. And at the end of the semester, we offered tests to any student that was returning home to immunocompromised relative. And so that's kind of that last section of testing there and how we made it through the semester. For the spring, we have arrival testing again. You can see we had some early arrivals. Not everyone came on the same weekend like they did as much in August. And so we have it spread out a little bit more. We did a lot of the at-home kits, and we did 3,800 tests for students and employees for our baseline testing. If there was a positive there, they either delayed arrival or they isolated on campus. Then January 26th through 31 was our first week of testing for surveillance. Again, that's the random sample and the wastewater follow-up. Our positive rate during that time was right around 1%, and we had 7 positive cases that first week. Obviously, all of these I'll share what happens once we have a positive, and I'll talk about that in a second. And then our second week, we tested 917. Positive rate actually stayed right under 1% there. And then last week, this is data ending through the 12th, we had testing surveillance volume still in the 900 and something tests. We had 16 student positives. 9 of those were symptomatic. 1 was a wastewater follow-up, and then 6 other positives. And our positive rate started to go up a little bit last week at 1.7. And we'll update the next week of data on the dashboard next Monday. And so that's kind of how the semester is looking so far this semester. Once there is a positive, what happens next is we do contact tracing. And after wastewater testing leads to individual testing, with individual testing then leads to contact tracing. And each positive case has an investigation that we conduct. Close contacts are defined as individuals who've been within a positive case for 6 feet for a cumulative total of 15 minutes or more. We have our own contact tracing team that works in very close partnership with the Ottawa County Department of Public Health. We have 7 individuals that do those contact tracing investigations. There was over 150 of them last fall, leading to 670 close contacts. A little bit of definition here. Isolation is when we house a student that is positive, separate from the community, and quarantine is when we house a close contact. So isolation and quarantine, effectively doing the same thing, but for those 2 different groups. On average, the ratio of close contacts in quarantine to positives in isolation is 4 to 1. So for every positive student we have, there's on average another 4 that quarantine as a close contact. And 7% of those close contacts have turned into a positive case isolating during their quarantine. So they were exposed as a close contact. We don't know who that is until we follow up and do this. And this is why it's so important, is a good number of those cases that we've had actually came out of close contacts. And so we were able to remove them from the community before it continues to spread through those individuals. So that's a little bit about contact tracing. We're fortunate to have Tim Coburna, the head athletic trainer, is the lead for our contact tracing efforts. And like I mentioned earlier, he does a great job partnering with Ottawa County Department of Public Health on all of this. Once we have a positive case and we have close contacts, we then move into quarantine and isolation, kind of the last step in that process. We're lucky to have a hotel facility on campus that we were able to, with less travel, with economy changing during a pandemic, and they did a remodel there, we were able to then use that space and still are for this purpose. And all positive cases are isolated and close contacts are quarantined. To help limit the spread, we follow the Ottawa County and CDC guidance. There have been some changes in some timings and things, so we're always working with them on the latest guidance and process for that. Like I mentioned, we have housing on campus for this. Students can isolate at home. They're not forced to go into this room at Hope. We offer that, and if they're able to and safely can, they can choose to isolate at home. And then they participate in classes remotely, and they all are assigned a trained advocate to work with them, making that whole experience as comfortable as possible. And that's a pretty amazing team and could be a topic of a whole nother webinar on how all that process works. And then the decision for when they return, again, following that those guidelines, but is made in consultation with healthcare providers, local health department, and then they come back into the residential community on campus. Just for a sense of scale, last fall we had up to 176 rooms available for this purpose. And then right now, as of when I looked at this information, I think last night, we have 12 students in isolation in campus housing, so mostly Hayworth there, and then 14 off, and then 9 currently quarantined with 20 quarantined in off-campus locations. That number fluctuates daily, and you can see the active case isolation number on that public dashboard. And Kristen Bachniak and Nicole Duntman from Residential Life are kind of our fearless leaders of this whole part of the process, and have worked with a great team of what we call COVID student advocates, working with them through that quarantine and isolation process. So I've mentioned some of the names. I'll show the picture here. This is just one team within a whole network of teams on campus that are responding during the pandemic. This is when we say test team, this is the group we're referring to. And it's been a real pleasure to work alongside them and continue to work alongside them this semester as we continue these practices.
Fantastic. Well, events like this always remind me how grateful I am that there are such intelligent individuals who follow their calling into the natural and applied sciences, and how their research and work truly impacts all of us in so many positive ways every day, especially right now. And one thing I've really observed about time in a pandemic is that sometimes time moves really, really fast, and other times it moves really slow. But the reality is that Hope has been making decisions about this pandemic for a year now. And that has allowed us to learn a number of lessons. I know as a CSA, we've even modified the COVID student advocate process quite a bit after experiencing it during the fall semester, because we're just able to learn things and make things better. So before we transition into the Q&A, we have some really good questions submitted, and I'm looking forward to hearing those answers. I would love it if Scott and Ben and Aaron could all share a lesson that they've learned as being a part of this process at Hope.
Thanks, Beth. Yeah. I think kind of one of the things that has struck me as we've gone through this, I'm fundamentally an academic person. And so a lot of the things that I do maybe are not relevant to daily life, at least not immediately. And this has been a huge change from that. And one of the things that I had to do sort of internally was to shift my perspective on what my projects look like. And so putting the effort into building up the wastewater based epidemiology approach here on campus is not an academic exercise. It's not one that I'm doing for research purposes. It's one that we're doing for decision-making purposes. And it has to be able to be done daily, and it has to be able to be done quickly, and it has to be able to be done cheaply. All of those things. We will get good experiences out of it. We will get good research experiences for students and all the things we usually do. But this is a more immediate thing. So that's one of the huge pivots that I had to make.
How about you, Ben?
Yeah, so a few things. One is just the idea of constraints. We had a lot of constraints early on, thinking about testing strategy, and there's a good side to constraints because it can help you come up with novel solutions. And so early on, there wasn't a whole lot of tests available. If we had all the tests in the world and we could test every student every day, we might not need wastewater testing, right? But by having those constraints in place of limited testing and supplies, we're able to come up with novel solutions that can be used going forward for other things.
Yeah, and I mentioned briefly the partnership with Ottawa County Department of Public Health, and I have to go back to that as a lesson learned of the importance of partnerships and thinking about teams and how they connect. So whether those teams were within Hope, or whether it was how are our teams working with county health officials. A lot of people comment about how Hope is lucky to have a town-gown relationship. That's a positive one. And I saw that firsthand, and a chance here to say thank you to Dr. Heidel and his team at Ottawa County Department of Public Health. That partnership continues to be huge. And then with watching teams work, I think importance of clear decision-making and kind of separating the roles out by different teams has been really helpful. And like Aaron and Ben mentioned, like we did this really quickly in July and August, having to respond and get ready for an in-person semester. And that required us to kind of work together quickly and find new ways to organize information and share that information. So I think being clear about those roles and having kind of talented teams put together in the right way makes a big difference.
Great. Well, I know that there's probably a lot more that you could share and that there's just a long list of things that we've learned, but we do have some really good questions submitted. And so it would be great, I think, if we could transition into those now. Dr. Kopek went ahead and answered a few of them, which is great, and shared some links and other information. But if you could go ahead and start to move into the questions that have been indicated to be answered live. A few of them could be bundled together. Some questions about comparing us versus the way that other colleges are monitoring their testing, and just work your way through that list.
All right, let's start with that. Aaron, maybe if you could speak to what other universities and colleges are doing this type of work, and how similar is it to what we're doing? A couple that were mentioned in the questions: University of Arizona, Johns Hopkins, were both referenced.
Okay. This is kind of in context of my perception of what others are doing, because I don't know exactly what everybody is doing. But I think one of the things that that the program that we're doing is, I think the frequency with which we're monitoring is higher with respect to wastewater than most places are doing. I think in my mind, when I think about these things, referencing the notion that the data have to be available immediately and they have to be actionable. I think that may be a different approach than many are using. The University of Arizona, I think, was the first example, at least public example, of monitoring wastewater out of a dorm, identifying a case or students that were infected, and then removing them from that. But I haven't really seen beyond that what the University of Arizona is doing, you know, on a daily basis. I know that there are other campuses that are using monitoring much like we are. Where it's hard to understand is how they're using that in their decision making. So is it that they're monitoring and the information is there, or is it that they're monitoring, the information is there, and they're using it for something? I think that's a distinction potentially that we have from others. So.
Another similar question on that topic, Aaron, for you. What other uses do you see on campuses or other organizations for this beyond the current pandemic?
Yeah, that's a great question. I mean, on a college campus, I wonder a little bit about the tolerance for monitoring wastewater coming out of these zones. If we continue to do that on a long-term basis, I think the pandemic is a different time, right? And so we have more tolerance there. I mean, it can be used for any number of things. We could monitor other disease burdens, right? You could monitor for norovirus. You could monitor for influenza. You could monitor for other types of diseases. So there are potential applications there. I think certainly at the community level that makes sense to do, because that's a larger population. And so you might be able to sort of anonymize sort of the results in some way. It doesn't affect individuals quite as much. And I don't know, I guess I'm hoping that, and I think I'm hearing some other people say these kinds of things, that what this will do, this pandemic sort of highlights the utility that utilizing wastewater as a monitoring approach can be applied, and it can be applied effectively. And even though it has been doing, people have been doing that for a long time, it hasn't really been in the limelight, right? Or it hasn't gotten a spotlight. And so I think that potentially that has the, well, it has the potential to increase the usage of it in the future, I think, in different ways.
Thanks. I'm kind of just going in order submitted here. Next one, I think I can answer, and then you guys can correct me if I got it right or not. The question is from David: comparing to clinical cases, what percentage of sewage testing individuals have been asymptomatic? I don't think we can actually answer that, because the way we do follow-up testing is, if you are experiencing symptoms, we don't have you go through our afternoon follow-up test center. And that's to keep symptomatic testing with a PCR test with our health center staff. There's a different level of PPE, different number of people around. When we know symptoms are present, we do that separately. So we wouldn't be able to answer how many wastewater follow-ups were asymptomatic versus symptomatic, because the way we do it, they're all asymptomatic. Does that make sense, Aaron and Ben? More or less.
Yeah, I think you're right. The ones we're finding with the wastewater generally are the asymptomatic, right? They don't know that they're they're positive. Otherwise, they would be, if they had symptoms, they would be going in and getting tested.
Next question is about, Aaron, you mentioned contacting legislators. The question is, have we done that? And do we know of any effect it's had on decision-making at the state of Michigan level?
Yeah, I mean, I know that there are various groups that sort of lobby on behalf of different organizations like HOPE. So the state level, the state-funded colleges, universities, but also the private colleges, universities. And I know that the example that we've got here has been sort of prominently put forth at those levels in meetings with the governor and other legislators and things like that. I don't know what the effect of those things are, right? So I don't know if that's causing people to take notice or to change the way they would be thinking about it. But I do think the more examples that we get like this, the harder it is to begin to ignore those kinds of things. So.
Our next question is kind of a fun one. Any correlations or things or trends that have stood out? And the example is the menu at Phelps. I don't think we have that correlated in any of our data. So kind of having some fun with the example there, but any trends or other things that stood out to you in doing this work that maybe are interesting or noteworthy?
Yeah, I always tried to correlate the pepper virus signal to burrito or Taco Tuesday night in Phelps, but I didn't see much of a correlation there.
I thought what Dr. Best shared about the correlation between cases identified in the community and the community wastewater signal, and seeing that as a leading indicator in that. I mean, that's a trend I think that you, Aaron, discovered, and we all found really interesting and helps us to really understand it. The other trend and kind of dynamic that I don't think we fully anticipated at the beginning was that effect of someone coming out of isolation and back into the residential community, where they're no longer contagious, but they're still shedding virus. We really had to wrestle with that one. And now we have to track who have we tested, when have we tested them, what day did they go in to isolation, what day did they come out, did they go home or did they come back to X residence hall, right? And so that's where having a team approach, where we have housing at the table, we have the people that are conducting the tests, we have the wastewater team at the table. A lot of times we all share different pieces of the story in order to put together what we think is really happening so that we can then act on it. That whole dynamic surprised me. Like, I just didn't think that we would need to track at that level, and to get the full picture, you really do. So that's a trend that jumped out to me.
Yeah, I agree. Kind of following on that trend, you know, the literature that's out there is a little bit sparse, right? Because it's a brand new sort of disease, and science has really been moving very fast. And the idea of preprints instead of having things peer reviewed before you see them has been huge, sort of in this pandemic. But some of the kind of information there with respect to shedding long term, you know, you see varying numbers, right, of the length of time that a person will shed virus after they're not infectious anymore. So after that 10-day period. And I think what's been interesting to me is just to see that on our campus, I don't really think that the signal lasts much longer than a week, maybe a week and a half at the outside. But in our experience, at least in our population, that those are the kinds of numbers we're seeing. And so what that means from an actionable standpoint is that you just have to understand what your new baseline becomes. So it's not like you can't see increases anymore. It's not, you're not blind anymore at the wastewater level. As long as you're aware of it, you know where your new signal is, and then you look for deviation from that for a little while. So it works out pretty well.
Yeah, I think what we're talking about right now ties in a little with the next question of, based on the strength of the signal, do you have any sense of how many positive cases might be in a zone based on what you're seeing in those two markers?
My short answer is no.
Yeah, I think that's kind of our ideal, our holy grail is to be able to do that. But yeah, the short answer is no. But I think we're kind of getting some general feel for how strong a signal is.
Yeah, I feel like, and you can correct me if I'm wrong here, I feel like we're dropping our threshold for what requires action over time as we begin to understand how sensitive the technique actually is, and that it really does represent people shedding virus at very low levels of detection. I do think I've seen differences in the magnitude of the signal. So the example that I showed, that I walked through, that had a magnitude of say 60. Okay, that was huge at the time. There were 7 people in that zone, I think, that came up as asymptomatic positives over that time period. That was the peak. Few weeks later, we have a peak of about 500, in sort of equivalent units, and it's 1 person. So those are the kind of anecdotes that you begin to see. I don't have data to show trends at this point on that, I think.
Yeah, and you've shared variables too, like even the way the sewage system is structured in a couple of our zones changes, like how long it takes matter to come through, and there's just the amount of things we've discovered that impact some of this are pretty crazy. Our next question is a little bit of what we've been talking about as well. How is HOPE distinguishing viral shedding for months post-infection from active infection in a student or community member? So we've already talked about that a little bit. But the follow-up here is a different question on specificity of PCR tests and how do we know true positives from false positives for our wastewater test results? And this is a question that came in from our Facebook Live broadcast.
Yeah, so with regards to the PCR, and it's not quite the same as a clinical PCR test that we're doing, although it's similar, right? So there are controls that we're able to do and to account for some of these things. But in a lot of ways, I think of the wastewater testing as kind of an initial test, right? It'd be one thing if we got a wastewater signal and we just said, okay, we're locking down that entire zone, but we don't do that. We see a signal and then we follow up with testing in that zone, right? So even if there was a false PCR signal from the wastewater signal, that's still followed up by individualized testing.
And I would add that we're often making decisions to follow up on more than one day's sample. So we're looking for trends of signal. It'll start to go up and it might be on the second day that we choose to act on it. And so there's often a few wastewater tests that are making up our decision making process. So that's another kind of guard against some false positives there. Next question is about stool samples been considered as they are more accurate and seeing up signaling a week prior to symptoms in wastewater. And this person wisely notes the ding on dignity, but may help thwart spread more quickly. The answer for that one is no. We've looked at tests we're using nasal and saliva-based tests, but we haven't looked at any other collection methods outside of the wastewater pool testing that Aaron outlined. Question on strains or variants. Does your testing show them? And if so, have we seen any of those?
We would like to do some looking at variants, but we're not yet looking for those. So the answer is no, we haven't seen anything because we're not looking yet.
Yeah, we're working on it. Should be doable.
Last question in here right now is what cycle time threshold for positive was used during the pool testing?
Yeah, this is getting down into details. So thanks for the question. The sort of the cycle threshold that we're using is, we aren't actually using cycle thresholds in our decision making, right? So the cycle threshold is what comes off of the instrument itself, and then we're translating that via various mechanisms into an actual concentration of virus or the number of copies of genes that we see. Then we're taking that and taking into account the efficiency of our process, as well as things like the levels of PMMOV and that kind of thing that are there. So what we're seeing is a lot more nuanced than looking simply at cycle thresholds for looking at our data. But I would say that the range of those cycle thresholds is probably in the 30 to 36 range generally. I don't think we've seen many down below 30 in the 20s.
Excellent. Way to work through that lengthy list of questions. Where a lot more information was able to be shared. I'm also really impressed with the things that our guests thought to ask all of you. So thank all of you so much for hanging on with us tonight and joining us to learn more about all this information. I just have to seize the opportunity to plug a couple of things that are important to the alumni and family engagement team. One of them is the Hope College Connection, which is our online platform, which offers a number of opportunities for you as alumni and families and students to connect with each other. You can access our online alumni directory. You can make connections with each other, with other students, and it has this really great matching function. So when you register as a user, you do have to answer a list of questions, but then the filter allows the Hope College Connection to connect you with people with similar interests, which is really exciting. So if you're not already a registered user, go ahead and visit connection.hope.edu to get signed up, or reach out to us if you have any questions with that process. And I also have to mention that Day of Giving is coming up at the end of this month, February 25 and 26. Hope students, as always, need the support that alumni and families and friends of the college have always shown them financially. And it is more important now than ever during the pandemic, as everything's just harder, including this, right? So something wonderful about Day of Giving is that you can choose to give to what you love. So you can designate your giving to your favorite department or program or the cause that you care about the most. I give to the communication department every year. So you can start thinking about who you'd want to designate your gift to, and stay tuned because you'll definitely be getting information in your email inbox about that. And you can visit hope.edu/give-to-hope, as you can see there on the screen, for more information about that. But most of all, I just want to say thank you to each of you for taking part in our event tonight. We're getting used to having these events online. If you told me a year ago this is how we'd be spending our evenings instead of like eating cookies and drinking coffee together, I would have thought you were crazy. Thank you so much to Dr. Best and Dr. Kopek and Scott for, giving us all of this information. That was just a lot. And I have so many more like ideas and thoughts going through my head, and I'm sure other people will too. So thanks for inciting that for all of us. Stay tuned for future online events. And again, one day we look forward to hosting you here on campus as well. And enjoy the rest of your Tuesday.